To determine the appropriate wire sizes for the service entrance and the feeder to the barn, we need to consider the ampacity requirements, the distance of the runs, and the applicable codes. For the lateral service entrance, which is 400 feet from the power company service hookup to the main panel is rated at 200 amps. Based on the NEC table 310.15b16 for a 200 amp service, you can use either 3/0 aluminum or 1/0 copper conductors. The conduit size for the lateral service entrance should be 2 inches. Moving on to the feeder wire to the barn, it is 200 feet from the main house panel and rated for 100 amps. Again referring to NEC table 310.15b16 for a 100 amp feeder, you can use 2/0 aluminum or 1/0 copper conductors. The conduit size for the feeder to the barn should be 1.5 inches. When selecting conductors, it's critical to consult NEC table 310.15b16, which provides ampacity ratings for various conductor types and sizes based on their insulation and temperature ratings. This table ensures that the conductors can safely carry the required current without overheating. The ampacity of a conductor is the maximum current in amps that it can carry continuously under specific conditions of use without exceeding its temperature rating. Different insulation types have different temperature ratings, and this affects their ampacity. For example, conductors with higher temperature ratings such as THHN or XHHW can carry more current than conductors with lower temperature ratings such as TW. When using NEC table 310.15b16, ensure you are using the correct column based on the conductor's insulation type and the termination temperature rating of the equipment. Typically, for equipment rated at 100 amps or less, you use the 60 degrees Celsius column, and for equipment rated over 100 amps, you use the 75 degrees Celsius column. However, always check the equipment's labeling to confirm the correct temperature rating. Voltage drop is another critical factor to consider, especially over long distances. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for feeders and 5% overall for feeders plus branch circuits. To calculate voltage drop, you can use the following formula: voltage drop equals 2 times K times I times D divided by Cm, where K is the constant for the conductor material, 12.9 ohms for copper, 21.2 ohms for aluminum, I is the current in amps, D is the one-way distance in feet, and Cm is the circular mils of the conductor. If the calculated voltage drop exceeds the recommended limits, you may need to increase the conductor size to reduce the resistance and lower the voltage drop. Conduit fill is also an important consideration. The NEC specifies the maximum percentage of conduit space that can be occupied by conductors. This is to ensure adequate heat dissipation and to prevent damage to the conductors during installation. The allowable conduit fill percentage varies depending on the number of conductors in the conduit. For example, for 3 or more conductors, the maximum fill is typically 40%. To calculate the conduit fill, you need to know the cross-sectional area of each conductor and the internal area of the conduit. The total area of the conductors must not exceed the allowable fill percentage of the conduit's internal area. Grounding and bonding are essential for electrical safety. The grounding system provides a path for fault current to flow back to the source, allowing the overcurrent protection device, circuit breaker or fuse to trip and to energize the circuit. Bonding ensures that all metallic parts of the electrical system are at the same electrical potential, reducing the risk of electric shock. The size of the grounding and bonding conductors is based on the size of the ungrounded conductors. Refer to NEC table 250.122 for the minimum size of equipment grounding conductors. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors and equipment from overloads and short circuits. The size of the overcurrent protection device should be matched to the ampacity of the conductor it is protecting. The NEC specifies the maximum overcurrent protection for various conductor sizes. For example, a 100 amp circuit requires a 100 amp circuit breaker or fuse. When selecting overcurrent protection devices, ensure they are properly rated for the voltage and interrupting rating of the electrical system. The interrupting rating is the maximum fault current that the device can safely interrupt. Local codes and regulations may have specific requirements that must be followed. These requirements may vary depending on the jurisdiction and the type of installation. Always consult with the local building department or a qualified electrical inspector to ensure compliance with all applicable codes and regulations. Licensed electricians have the knowledge and experience to perform electrical installations safely and correctly. They are familiar with the NEC and local codes and regulations. Hiring a licensed electrician can help ensure that the electrical system is installed properly and meets all safety requirements. Always verify that the electrician is licensed and insured before hiring them. Permits are typically required for electrical installations. A permit is a legal document that authorizes the electrical work to be performed. The permit process helps ensure that the electrical installation is inspected and meets all applicable codes and regulations. Contact the local building department to obtain the necessary permits before starting any electrical work. Inspections are performed by qualified electrical inspectors to verify that the electrical installation meets all applicable codes and regulations. The inspector will review the electrical plans, inspect the wiring and equipment, and ensure that the installation is safe and compliant. Schedule an inspection after the electrical work is completed and before energizing the circuit. Documentation is essential for electrical installations. Keep accurate records of the electrical plans, permits, inspection reports, and equipment specifications. This documentation can be helpful for future maintenance, repairs, or modifications to the electrical system. Store the documentation in a safe and accessible location. Safety precautions should always be followed when working with electricity. Electricity can be dangerous and can cause serious injury or death. Always de-energize the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, hire a licensed electrician to perform the work. Proper grounding ensures a safe path for electrical current in the event of a fault. It helps to minimize the risk of electrical shock and prevents damage to equipment. Grounding involves connecting all non-current carrying metal parts of the electrical system to the earth, providing a lower impedance path for fault current to flow back to the source. Grounding electrodes, such as ground rods or metal water pipes, are used to establish the connection to the earth. The size and type of grounding electrode required depend on the size of the electrical system and local codes. Bonding involves connecting all metallic parts of the electrical system together to create a continuous electrical path. This ensures that all metal parts are at the same electrical potential, reducing the risk of electric shock. Bonding is typically accomplished using bonding jumpers or bonding screws. The size of the bonding conductors is based on the size of the ungrounded conductors. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes, power outages, or other electrical disturbances. Voltage surges can damage or destroy sensitive electronic equipment such as computers, televisions, and appliances. SPD divert the excess voltage to ground, protecting the equipment from damage. SPD are typically installed at the service entrance and at branch circuits that serve sensitive electronic equipment. Arc fault circuit interrupters, or AFSIs, are designed to protect against electrical fires caused by arc faults. Arc faults are dangerous electrical discharges that can occur when damaged or deteriorated wiring creates a high-resistance connection. AFSIs detect arc faults and quickly de-energize the circuit, preventing a fire from starting. AFSIs are required in many areas of the home, such as bedrooms, living rooms, and hallways. Ground fault circuit interrupters, or GFCIs, are designed to protect against electrical shock caused by ground faults. Ground faults occur when electrical current flows through an unintended path to ground, such as through a person's body. GFCIs detect ground faults and quickly de-energize the circuit, preventing electrical shock. GFCIs are required in areas where there is a risk of exposure to water, such as bathrooms, kitchens, and outdoor locations. Electrical boxes are used to enclose and protect electrical connections. They provide a safe and secure location for splicing wires and mounting electrical devices, such as switches and receptacles. Electrical boxes are available in various sizes and materials depending on the application. Metal boxes are typically used for exposed locations, while non-metallic boxes are used for concealed locations. The size of the electrical box required depends on the number of conductors and devices it will contain. Wiring methods refer to the way electrical conductors are installed and protected. Common wiring methods include rigid metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic sheathed cable. The wiring method used depends on the application, the environment, and local codes. Rigid metal conduit provides the highest level of protection for conductors and is typically used in exposed locations or where there is a risk of physical damage. Non-metallic sheathed cable, also known as Romex, is commonly used for residential wiring in concealed locations. The choice of conductor material, whether copper or aluminum, depends on several factors, including cost, weight, and conductivity. Copper has higher conductivity than aluminum, meaning it can carry more current for a given size. However, aluminum is lighter and less expensive than copper. Aluminum conductors are typically used for larger sizes, such as service entrance conductors, while copper conductors are used for smaller sizes, such as branch circuit wiring. When using aluminum conductors, it is important to use connectors and terminals that are specifically designed for aluminum. These connectors are typically made of aluminum and are coated with an antioxidant compound to prevent corrosion. Regular maintenance and inspection of the electrical system are essential for ensuring its safety and reliability. Inspect the wiring, connections, and equipment for any signs of damage or deterioration. Replace any worn or damaged components promptly. Test the GFCIs and their size regularly to ensure they are functioning properly. Keep the electrical panel clean and free of obstructions. Never overload circuits by plugging too many devices into a single outlet. Use power strips with surge protection to protect sensitive electronic equipment. Be aware of the signs of electrical problems, such as flickering lights, sparking outlets, or burning smells. If you notice any of these problems, contact a licensed electrician immediately. Never attempt to repair electrical problems yourself unless you are a qualified electrician. Working with electricity can be dangerous and can cause serious injury or death. Always follow safe work practices and use appropriate personal protective equipment. If you are not comfortable working with electricity, hire a licensed electrician to perform the work. Remember that these calculations and recommendations are for informational purposes only. Always consult with a qualified electrician and local building codes and regulations for specific requirements in your area. It is essential to ensure safety and compliance with all applicable codes and regulations to protect yourself and others from electrical hazards.